die Präsentation auf den Beamer kriegt.
Willst du aber kurz schauen? Mal kurz, wenn jemand da ist.
Ja, eigentlich schon. Ja. Achso, ist er schon. Ja, sehr gut.
Aber nur ich. Ne?
Der Punkt ist der, wie kommen die nächsten Slides drauf? Ich glaube, wir müssten jetzt drauf sein. Genau, das sind sie ja. Genau. Das sind wir ja komplett. Ja. Haben wir noch 3 Minuten noch und dann können wir. So, please start. Yeah, how should we start? How about the habit? Should we wait 3 minutes?
All presentations there.
Yeah. Let's start the first one. Excellent. Yeah. Thanks a lot. So please have your seat. I think it's time. Just wait maybe 2 minutes and then we start. Please have a seat. So good afternoon, everyone. I think it's time to start with the panel because otherwise we run out of time. So my name is Markus Dillinger. I'm with Harvey Germany here, and I have the honor to be the panel host for this afternoon panel, the first panel of EuCNC. And we have also distinguished speakers here. You see already 5 colleagues on the seats. I will introduce them very briefly. So this topic, evolving requirements, deployment, challenges, business cases, is actually not a new topic. It's a burning topic. We have, since 3 years, many discussions, and we still have not really achieved consensus on that. So we have to discuss what is the current status and what is the way forward. To our panelists, so we have from the left, we have Mikael Fallgreen. You see also the faces. We have here also Zexian from Nokia. We have Dr. Andreas Mueller from 5G a board member. He's the chairman of the board, but also from Bosch. We have Mikael Nilsson. He is in the middle. He is senior researcher from Volvo cars. And we have Mr. Andersson. He's rapporteur from the Radio Special Interest Group working on 5G. So we have a very interesting panel, and the storyboard is as follows. We introduce one speaker by another by making his statements. And then after all this, we will invite you for questions. But first, we will discuss internally, give you a teaser, what are the questions we see towards each other. And then maybe the last 20 minutes, we invite your audience. We have also a microphone here. This will be handed over to you to also answer your burning questions. So I hope that all, after this 90 minutes, we have more answers than, let's say, questions on that. I will try to give you a teaser. What is the current status on these 5G verticals? Actually, we started here under the framework of 5GP 2.5 years ago to submit white papers on e-health, smart grid, Industry 4.0, and connected cars. And it became quite silent for e-health and for smart grid. But what is now really burning is the topic around V2X, 5G V2X. It's a topic about industrial internet, so smart manufacturing supporting or involving 5G. And the slide you see here is actually trying to illustrate what is the need for 5G, because we will have services you can do with LT or with IPv technologies. And what is the market impact, let's say, on that? When we start from the left side, we see actually that the Connected Cooperative Automated Mobility, the CCAM we call it also, has the highest need for 5G. This includes V2V, V2I, V2N. and has also potentially the highest market impacts for all of us, and also on the society. This is still an open point. But we have also use cases which you might do, like driver info. You can do this with LTE. Okay, this is text message, whatever, infotainment. But you see also a high need for entertainment. As soon as you have robot cars, you have really a lot of time to consume videos in the car. So in that case, you need also very strong 5G deployments along the roads. So this is somehow this magic triangle for V2X. We see on the right side actually the strong demand for connectivity. So the idea is actually to replace the wire by wireless. So the robot is then connected to the cloud in the factory by 5G. This is the idea. But we see also other use cases you can do with other technologies. Let's say predictive maintenance is potentially a low bitrate service. Here you could see the border for 5G and non-5G. So what is above the circle is the strong requirement or the strong recommendation to use 5G. And below we can also argue for 4G or other technologies. So this is somehow setting the scene actually on the market point. Now let's dive into the use cases. We have here, when we talk to connected cars, a very complex use case composition. So we have a low bit rate up to very high bit rate services. We can have information from parked cars. We can have, let's say, see-through or streaming services from cars. So going into MBB-like services, but also we see the need for some kinds of platooning between cars, where you need this short messages, control loops, URC-type messages between cars. But also we have a strong need for safety. The safety you can do with, let's call it LMMFE or LTV2X, it is 14, being complemented by this, let's say, higher 5G service demand, autonomous driving, what you see on the left side of the slide. Then the telematics is actually what we call driver infotainment or driver information. This is also to be supposed by the 5G network or by the networks. The right side is for the passengers as well. So the idea is to have one network actually which provides ITS services and infotainment services to save money. It doesn't make sense to have separate networks. When it comes to the smart factoring, we see a little bit a different view on that. We have particular small devices or dedicated devices like robots, like sensors, which run one service. The sensor runs MTC service, the robot may run URC service, but maybe also MBB. But it's not so complex like the car. The car is a real complex composition of all kinds of services. But we have other more stringent requirements. This is defined over the latency or the cycle time or round-trip delay. It's much harsher than in V2X. Some people believe we need 8 nines instead of the famous 5 nines. We have also a high demand on availability. So that means the downtime should be more or less 0, so that there's not a problem with production. And we see a strong need for extension of the URC. We call it time-sensitive networks, TSN, which controls the jitter, and not just an average control of the feedback delay. So it's more diverse, but more dedicated for unique devices. On the right side, you see some examples here, like tool localization, HEV localization, and in general, robot connectivity. When it comes to network, it's also more complex than with V2X. We have V2X, general purpose is to use public networks. But here we have different options. We could have the slicing option, that means to slice a public network for private purposes. We can have a dedicated network. Type A is that you have a factory network and you can have roaming agreements with the public network. This is needed for logistic. The type B is actually a fully closed network, a private network where you really terminate all communications before you go out. So the requirement is that the firewall, before you reach it, it must be terminated. And this is quite diverse, and the question is also about spectrum, we'll discuss later. On the right side, you see actually the TSN flavor. TSN is well defined on the wire, but the aim is to get TSN into the wireless domain as well. This is the 5G. So 5G must also have its evolution towards TSN. Now, coming from a higher perspective, what is the enablement for all this business? So we need, of course, the product, this is clear, fulfilling all these 3GP requirements. But we need also to discuss the spectrum. Where's the spectrum? How much do we need? For example, from 5G point of view, they have defined 170 megahertz, 30 megahertz are for safety, another 140 are for discomfort driving use cases. Whereas under the 5G ASIA, they are still discussing what is the exact amount, maybe 100 megahertz, maybe more. Then important for the cars, for the mission critical machines are the certification. So here the requirement for functional safety steps in. We need to ensure that we don't have any accidents or fatalities. This is not a smartphone on four wheels anymore. This is important. When it comes to standardization, it's getting also more complex because the 5G is not only there for infotainment, it is supposed also to be integrated to the machine, to the car, and to change the machine behavior. Changing machine behavior means you must define other minimum performance requirements compared to that what we have. Today we have everything based on sensors in the cars. And of course we have some problems with sensor-only communication or sensing. Then when you add to the sensor the communication, you might change also the performance requirements in existing ISO standards or IEC standards. So this is to be done on the vertical side. The 3GP people have understood that, but it's not end-to-end solution. We need also to change existing, I would say, machine standards or OEM standards. This is needed. Then, of course, the number 5 is to agree on the government policies when we go to connected cars again. It's very complex because we need to involve the road operators, we need to involve legacy cars. Not all cars have 5G. We will have old-timers and battery connected cars. So here also the government must invest, and we have seen this morning that also idea from the Commission in the CEF framework to invest into 5G highways. This is good news. We have to look also on privacy. It's not so easy because just recording videos and sending to the cloud from the street to the cloud is not allowed. You must remove personal information, plate and faces and so on. This is also an issue. So what kind of immense sensor sharing is actually applicable when it comes to GDPR? From the business case of view, we will elaborate on that later. It's also, when we go to V2X again, it's complex, but we have tried to digest this business analysis in a white paper provided by the 5G Automotive Working Group in 5GP. This paper was published under the Mobile World Congress this year. And actually, it calculates really on the cent accuracy what you have to take in and what you can spend. And what we understand is that we can have a very fast return of investment when we have a 5G highway and we have these advanced cars. With that I mean that we have a drive as pay per service, so that you may have a highway segment where you equip with 5G base stations and fiber, and you are willing to pay maybe €1 per 100 kilometer and then to sleep, okay? So that in that case, you don't need to drive the car anymore. And when you have a very dense, packed highway, let's say 200,000 drivers per day, then you have a very good business, actually. The problem is how to get to that. This is the issue. So how to solve these regulations, the policymakers, the road infrastructure providers, and to synchronize OEM standards and 3GP standards. This is a challenge. Coming more to technical issues from 3GP SA1, you see here for 5G new radio V2X, the use cases on the left side, and what does it mean in terms of performance requirements. So we have a very complicated mapping, and from the middle column, you have to map to different technical components on the right side. And to really advance these use cases or to enable these use cases. And the good news is that last week, the RAN plenary has decided to go for a study and work item on release 16 for V2X, which means there will be the side link, also running in licensed spectrum and unlicensed spectrum, and running also the low latency URC over side link for platooning and so on. This is a very good move, actually. There are also other work items underway for positioning over 5G. So these are all ingredients which are needed to implement this CCAM or autonomous driving in the future. On the right side, you see potential time slots. So release 16 should be supposed by end of next year. Release 17 is then the next 18 months, so middle of 2020 then, or 2021. So you see it's quite diverse, but it's even more diverse when it goes to Industry 4.0. So we have much more use cases. We have even more complex mapping to performance requirements. I mentioned already the 5 nines going up to 8 nines. The massive number is increasing of nodes. We have even less than 1 millisecond. We might go to microseconds. It goes to Profinet bus and so on. Cycle time is very challenging. I mentioned the TSN already. And you see, again, all the technical enablers. You have TSN. We have, again, enhanced URC going into smaller cycle time, so much less than maybe 5G. Maybe we talk also already 6G, that we have less latency requirements here. Questions, we will discuss this in more detail. Just a teaser for you, but we still have to discuss the business models, the spectrum issues, private, public networks, and so on. So that's all from my side. I would like to hand over then to the next speaker, Mikael, to give a statement from Ericsson's side. Okay.
Yes. Thank you, Markus. Warm welcome here from my side as well. So my name is Mikael Fallgreen, and I work at Ericsson Research. As a senior researcher, I'm project coordinator of a project called 5G Car. So I'll bring in one business cases example from that project. And I'm also chairman for the 5G Automotive Working Group, one of the figures that Markus showed. So I will dig in a little bit more on the deployment challenges based on that example. But I will start off with sort of the 5G for verticals, and then also look from the other perspective in terms of sort of impact on the verticals due to sort of 5G and the challenges, but also, of course, opportunities that there is. So 5G, one way of categorizing this is from IMT 2020, sort of the 5G network service categories. So the enhanced mobile broadband sort of building and continuing that direction, but perhaps the new thing with 5G is rather the other dimensions and being able to select slices depending on what type of needs that you have. So in addition to sort of building out the mobile broadband, also focusing on URLLC, so the ultra reliable and also low latency type of applications that you need. And also the other and third dimension then is the massive MTC with small sensors and maybe grouping them together and doing clever things in order to collect various type of information, for example. So these type of dimensions then, of course, enable us to think about a wide range of use cases and then also requirements that can be addressed by these type of solutions that are being developed. And thereby also branding out sort of from this beyond mobile broadband, where one are still wanting to build out and provide better experience everywhere, anytime. But in addition to the broadband then, enabling, for example, mass market on personalized media and gaming for different users that want to play on various type of platforms. And overall, there's more and more human interaction with the machines coming. For example, you can remotely start controlling machines. So you have one driver, and then you can jump around doing more tricky things, for example, towards health surgery, or maybe another towards forestry. You sort of monitor one of these bigger machines remotely then. Another big topic is automotive, which I will dig into more in terms of my examples also, where we want to enable a smart transport infrastructure for these vehicles then. And the MTC that I highlighted, sort of meter sensors and these type of devices. So many different things are, of course, ongoing. And the challenge is now to bring this together into these new ecosystems and make it viable and feasible. And so on. So one big arena where things are happening is, of course, in the industry. So automotive, but also sort of other type of industries, which we'll hear more about here later. Another big impact on the ecosystem is, of course, you as a private consumer, the different ranges that you see of various type of applications. Another is more on the society as a whole, where you have public sectors being able to benefit from these various type of services being developed. And also the ones that are providing these services, or network operators, perhaps these new dimensions mean that one need to adopt the network somehow in clever ways to enable these type of services in a good and sort of cost-efficient way. So here below I just list some number of verticals as examples. There are of course many more. The automotive factor I mentioned, also media, more futuristic, perhaps more augmented reality, and also building up virtual realities that we sort of can't see here around us, but then create them virtually. And then the healthcare, which I stressed, agriculture, perhaps I didn't mention, but that is of course also one big important area where you can benefit. And also energy is one of them. Also smart cities and many more, of course. So the impact sort of 5G on these verticals. Okay, we are coming here with new technology aspects. One want to leverage, of course, if you already have a system, you want to leverage on your existing infrastructure and the device support that you already have. But at the same time, that one can now be complemented by 5G radio technology. And the idea is then that you can bring that for more advanced services. But then there, of course, are challenges and things to address. So here I highlight a few of them: business, power consumption, security, spectrum, legal aspects. So in terms of business, finding different type of services, but the crucial part might be to localize how to generate the income in the end to pay for this extended infrastructure, for example. So one important question is who should and will in the end pay for these type of services? And I guess many times it's the end users that will want to chip in at least. And also building out these systems, we still need to think about the total amount of power consumption. And for example, even if the system as a whole maybe use slightly more energy, perhaps it could save energy in other sources by making clever decisions. I heard one example from Professor Tommy Svensson yesterday, who in terms of power consumption, sometimes the airplanes when landing have to circle around the city for quite some time before going down. If you could plan ahead and make the plane fly slower and then sort of being able to land immediately, of course, that's a great way of saving fuel, for example. Same thing with the traffic jams. If all cars get stuck, of course, that is not so good, and or even that you're just driving slower speeds compared to what would be feasible otherwise. But also, when we're starting to collecting more and more information together, for example, positions of different type of devices and so on, it also becomes very important with being able to ensure the secure part of it, avoid potential attacks, and also ensure privacy of different type of data that you may not want to share. Some parts you're of course happy to share, but other type of data you want to keep to yourself perhaps, or to your close ones. Another challenge is, as I see it, the legal aspects to make this entire system viable, and GDPR, the Global Data Protection Rule, is, I think, one way to move sort of in this direction. So this is an EU law that's been finalized early this year. So these two examples that I highlighted, one on these deployment challenges. So this figure or picture is the one that Markus showed earlier also. This is from the 5G Automotive Working Group, which is a working group where people from different 5G PPP phase projects and so on are coming together and can work on V2X related topic that spans sort of a large scope. So in terms of descriptions and the actual white paper, you can find under these links here. But if you zoom into the figure, we highlight the automotive industry and 5G industry. So telecommunication and the automotive industry coming together and working on sort of common solutions for this field. And that collaboration is, of course, ongoing, as you know. But you also want to bring in the standardization. Before, perhaps you had two parallel tracks, one for the telecom sector and one for the automotive sector. One challenge now could be to bring these, find a common standard for things that need to be common. Also, changing the system, policymakers will need to adapt regulation. Maybe in this regulation, of course, point to all different types of places where to bring in the 5G deployment. In this illustration and this example, the idea is we're looking on a highway where the road infrastructure operators then have sort of the 5G deployment along the road. But this is just one example then, as I said. And then in the end, then the users, drivers, are enjoying these type of services then. Also one example on business models. So this example comes from the 5G car project and sort of the intermediate results. So this is after 1 year, and then there's 1 more year of the project to go. Overall, we looked into the current value chains, which you see to the left. So one is sort of the telecom sector. You have the telecom equipment vendor providing sort of to the mobile network operator, building up sort of the infrastructure, and then the mobile network operator is then providing to the end user. So EU here is end user. While in the automotive sector, you then have automotive supplier instead providing to the OEM, building the cars and then providing these then to the end users again. But then we foresee a transition here into possible ecosystems in the future. And you see various examples here, and they are created from, typically you might think sort of that wherever you happen to be, for example, a telecom equipment vendor, you tend to see yourself in the center. So the first illustration is sort of from a telecom equipment vendor perspective and how you see that you will interact with all the others and see yourself as the central figure. Next one is OEM sort of as the center figure, where is the interaction from the OEM perspective. Same then for mobile network operator and then automotive supplier. And maybe sort of, I mean, in the end, maybe there will be something in between here. That will be the final way of putting the pieces together. But this is just sort of a trigger for thought. Thank you.
Thanks.
Okay, so my name is Zexian, so welcome to join this session from my behalf. I'm from Nokia Bell Labs. So today, since our kind of the main topic here is about the, sorry, thank you. It's about this verticals. So let me start from this verticals when we're discussing, and then, I mean, there are quite many different ways when we try to categorize what the use case for the verticals. I'm just taking some example, for example, from here. One major part looking is on the factory automation here. And then, of course, one quite popular use case we are discussing is about mobile robot. And then here, of course, the requirements when we're looking about these different use cases, they are quite, changed a lot. Even thinking about factory automation, I mean, the mobile robot or this motion control, which give us the most strict requirements in terms of, for example, the availability, latency, and jitter. And also, as Markus already mentioned, for example, when we're talking about to support the time-sensitive network, and then the synchronization requirements among the different devices, that also becomes quite challenging. At least in the earlier cellular technology, we have not been really considered that type of requirement before. Then on the other hand, also in the factory environments, there are also different sensor devices, for example, monitoring temperature, monitoring other stuff. So that's also give us that a different type of use cases, which could be mostly smaller data packet, and then there's not need to be too often data transmission, etc. So that's kind of when we are thinking about the usage scenarios, which has been discussed no matter in the standard or in the different research work. So it's more like, for example, the different type of massive MTC application and also this ultra reliable low latency communications, plus the enhanced mobile broadband. Then mostly this factory automation, I mean, mostly is focused on the local area, or at least in the restricted area. And then if you are looking a bit on the wide area scenarios, I'm taking here like two examples. One is this smart grid protection and control. So in that case, it's more like when you have the substation, they need to change information, or relay station, they need to exchange information between each other. And then in case one relay station, for example, out of order, then it should be really fast to inform the others to avoid to have the large area blockouts. So that's a major kind of one use case has been discussed. Then another one, yeah, I will talk a bit more here. I mean, since also myself involved in the 5G car project and mainly responsible for this radio air interface discussion there. So I will focus a bit more on the following slides on the autonomous vehicles there. Then if we are looking about fully autonomous vehicles, so the main target, what we are trying to achieve is trying to, how to say, create kind of a living room experience in the vehicle. So today, when we are talking about, for example, this autonomous driving or autonomous vehicles, mostly the cellular technology or this different V2X communication has not been really taken into account. So it's mainly based on the sensors or cameras, lidars, equipment in the car, and then trying to get the data and then doing some local processing, and then the car will make a decision what kind of action to be taken. And then what we are thinking that, for example, when we try to build the V2X communication, then we can bring further enhancements. For example, we can have high these HD maps, and even in some cases, for example, some local area map which can be delivered to the car, which can help for the car to making the better decision. And also, if you are thinking about full V2X connectivity there, that one even can give better, for example, especially we have been talking about the V2V or V2P or all type of different communications. That one will be applied, for example, to support different ITS, the service or safety-related communications, and that also kind of bring very much help to fulfill the requirements from these fully autonomous vehicles, etc. And of course, this AI and self-learning will also bring a role as well when we are looking a bit long-term what happens in the autonomous vehicles. Then about these different traffic scenarios or use cases, and I think Markus also mentioned about these different type of service. If you are thinking about how to support autonomous vehicles and also thinking about the user inside of the vehicles. So if we start from the user side, anyway, the major use case thinking about what you can do in the living room, like playing games, watching video, doing the internet browsing, consuming multimedia content, etc. That type of service most likely is more like eMBB type of service. And very high bandwidth there is needed, and also the speed. But then from the high reliability or this latency point of view, it can be a bit relaxed. And then another type of service or kind of use case coming from here is about the traffic efficiency. One example here is like, for example, in case of platoon type of operation, and then you can have the efficient like navigation and also trying to see that how much distance between the car, etc. And also that's related to the traffic safety as well. But that is another use case that's how to improve the traffic efficiency in general. For example, to reduce the consumption of the petrol, etc. So that is another type of use cases when we're talking about these fully autonomous vehicles. And then safety, traffic safety, this is also quite how to say, the very hot topic when we're discussing about different to support autonomous vehicles from the safety point of view. In the current, for example, in the current discussion, mostly, no matter thinking about LTE or from this 802.11p aspect, we are mainly looking about this CAM type of message or DIM type of message. But then that's also like what has been happening already today. But then if you are looking about these autonomous vehicles driving there, if we really trying to kind of achieve the best benefit from all these autonomous drivings, then we need to really have the much lower latency for the communications, and also from the reliability point of view, that should be really high. So that's more or less leading us to different requirements, thinking about how to design the V2X communications. Then from our thinking that it's mainly like how to say, as also indicated by the speaker in the morning. So one major target is how to try to leverage the cellular technology, technology to meet the autonomous industry needs for the reliable and also enhanced V2X communication. Here, I mean, basically we should keep in mind that also as discussed, for V2X communication, there are different types of needs. And also it depends on different type of use cases, and then the need, we need to find the best solution to support the use cases at the end user requirement. Then I could give kind of very high level to see what kind of V2X communication could happen, and also could have been already discussed in the different areas, including 3GPP. And if we start from here, if you see that, for example, this end user, like a living room experience type of service, that's usually, as I mentioned, is more like a mobile broadband. So usually for that type of service, for example, you can go to the V2N, so vehicle to network type of communication. And then also, of course, depends on the content, this mobile edge computing or this edge cloud play a role there as well, trying to efficiently distribute the content, for example. Then thinking about, for example, this car maintenance type of service, or this kind of software download, etc. That's also can do in a similar way. For example, you go to the V2N, and then you have some kind of a server from the car vendor, these OEMs, and then you can achieve the software downloads, this kind of maintenance service to keeping the data into the server part. And then about the safety related, I mean, it's more like, for example, we had possibility to have the V2I, so that's the vehicle to the infrastructure, like have the communication with the traffic light and also the roadside unit can provide some more information. And also because for the safety related information, mostly the data is much more valuable in the local area, in the local geographic area. So in that way, we are also thinking that this mobile edge computing or this mobile edge cloud play a very key role there during distribute such kind of information. And of course, I mean, when we're talking about V2X communication, we need to really keep in mind that actually it's not V2X communication alone to support the autonomous vehicles. And then this sensor or leader or all the technology, what is available today, and also to have further enhancement that will continue to play a very key role there as well. The V2X part is more like, for example, you can increase the communication distance, and then you can get, how to say, like in case the weather is not good, for example, for the sensor to working, then the V2X communication definitely can help as well. Spectrum, I think we will discuss a bit more in the later phase, and then here just to have some discussion that in the 5G, you know, we are discussing quite a broad range of the potential spectrum. And then if you are thinking about how to support verticals, of course, there are different options. And also, I think all the different options are under discussion as well. For example, you can have exclusive usage. That means you could have some dedicated spectrum for some vertical use case. And then you can also have the, how to say this, for example, this license shared access, which means that the verticals can get some shared license the spectrum, but then it's not, how to say, it's more like a predictive. For example, you can use it during a certain time period, etc. And also, of course, there are also the purely shared approach, but then the problem there is that you cannot guarantee any kind of QoS. But of course, in case of the use case do not bring any strict requirement, then you can also using the shared spectrum as another alternative to support the vertical use cases. Then I mean, thinking about the cooperation basically between the different industries. I mean, when we're looking at what's discussing about 5G to support verticals, I mean, basically verticals are evolving no matter from the platform, from the technology. They are going ahead all the time. Similarly happens in the telecom world. So basically, it's very important to have very close cooperation between the different industries. I give some example here, like for example, we have this 5G ACIA, which is mainly looking about this industry use cases, and then 5G AA is mainly looking about this autonomous scenarios, and then 5G car, as I mentioned, this is more like our 5G PPP phase 2 project. So I mean, it's really important trying to, understand what's the restriction from, for example, from the real implementation point of view. And then, by example, I mean, if you are thinking about, for example, from the telecom area, we are pushing some, let's say, net features, but then when we come to the real implementation, it could be a problem. So that's the reason why, from our side, we have been thinking that it's very important trying to have very close cooperation, and very happy to see that it happens nowadays, like in the different areas. We're really trying to bridge the different industries together, and then trying to find the promising technology which can be applied in the future, and also really changing our daily life. So that's more or less what I have in mind. Thank you.
Okay, thanks.
Speak faster. Which key to press? Which key to press, please? So, welcome. My name is Mikael Nilsson from Volvo Car Corporation. Today I'm representing the automotive industry in the vertical sector in the 5G industry. So your life, your car is connected today. And Volvo Cars' aim is to make the life of our customers more enjoyable, easier, and saving time for them. So, of course, we start with safety. We have connected safety, for example, slippery road detection system today, that we send up information to our cloud. And we have also started to share our information, our cloud, with other OEMs' clouds. We have started cooperation with the AB Volvo, the company AB Volvo doing the trucks and buses. Of course, we have the infotainment system, streaming media, Skype conference, and so on in the self-driving cars in the future. We connect our vehicles to the workshops through the cloud. We have the Volvo On Call system that we launched in '99, where we had the accident. It's informed an emergency call center, and almost 20 years later, now it is a legislation in Europe to have this as a standard. So that is really helping the safety when we connect our cars. And of course, in the future, when we have our autonomous cars, we will need to update, we have really good maps of the environment, the near environment, and the traffic situation of the car. So new business opportunity enabled by 5G. We see, for example, network slicing is a very interesting topic, that actually the cost adapts to the actual needs, and not instead one size fits all that it is according today for the cellular system. Another interesting area is the virtualization of the network. This means that new actors leveraging economies of scale plus pressure on today's companies. And there we will see what's happening in the future. And also, previously mentioned here, mobile edge computing. How can that help vehicle-to-X communication? And maybe there will be potential new revenue streams for the network operators. So we have these communication links. I will not repeat them. You've seen them before. But I would like to mention that, for example, the vehicle-to-vehicle communication, there is this unlicensed spectrum at 5.9 gigahertz. It will definitely fulfill the purpose that we have today and will have for the day 1 and day 2 use cases, which have been standardized by ETSI and so on. But when we are discussing in long term, the day 3 or day 4, or when we have self-driving cars on level 5, according to SAE standard, probably we need much larger bandwidth for cooperative perception. And we need more spectrum for the vehicle-to-vehicle communication, and we will also have communication to the cloud. And that is today basically only communicated on licensed spectrum. But will that be the case in the future as well? Can we only have private networks, so to say, or do we need public networks, a digital infrastructure along the roads? So, to end with, as Volvo Cars, safety is first, have always been since we were founded in 1927. So, safety is for all, and if safety data to provide nearly for free of charge, then who pays? That is, I think, a really big challenge. We might solve the technical challenge, but the business models needs also to be solved. Thank you.
Yeah, thank you.
Hello, ladies and gentlemen. Thanks for having me. My name is Andreas Mueller. I'm the head of communication and network technology in Bosch Corporate Research in Stuttgart, Germany. And I'm also the chairman of this newly established 5G Alliance for Connected Industries and Automation, 5G ACIA. We have heard it before. Maybe you haven't heard a lot about it yet, but you will still hear a lot from us in the future. And I will talk about 5G manufacturing. So we have heard enough about automotive applications. And now the focus is more on manufacturing. And since we are such an intimate group today, I want to tell you a secret, but please keep it for you. So I will tell you what a kill application of 5G will be. And of course, there are several candidates for that. I mean, we have heard some ideas already from the previous speakers. Also the conference, of course, is a lot about different applications of 5G. And the usual suspects are probably those that are listed here: consumer, automotive, manufacturing, some smaller ones, smart cities, and the like. And the question is, what is really the killer application of 5G? Well, it's really not consumer. I mean, that's where the mobile industry comes from. But the consumer market is saturated. So everybody has a flat rate, everybody has a smartphone. You cannot really get a lot of additional revenue out of the consumer industry. So therefore, it's certainly not the killer application. Automotive, I'm sorry guys, but it's also not a kill application. Everybody is talking about automotive, you can have nice use cases and so on. But it requires huge investments. You need really a good infrastructure, a nationwide infrastructure, and the value add is rather limited. It's about safety, we've heard about this before, nobody's willing to pay for safety, you just expect that it's safe. Even without connectivity, it has to be safe. Then it's about infotainment, but then we are in the consumer domain again. So the value add really is very limited. So then we have smart cities. The problem with smart cities is that there are many interesting, nice applications, the smart dustbin, the smart lamppost, and so on. But these are all very small niches. And every niche by itself basically is not attractive enough. And we see that there are many startups, some make some profit, but many also go bankrupt. And therefore the question is really, what is the business case and the business model for smart cities? And then we have Industry 4.0 manufacturing. And smart manufacturing, in my honest opinion, will be the killer application for 5G because there's a huge economic potential in it. If we can just increase the productivity of a factory by 1%, we are talking about billions of euros that we can gain. And we can achieve this with very limited investments. I mean, we don't need a nationwide coverage. We don't need these 6 or 8 nines and 1 millisecond all over Germany or all over Europe. We need it in a factory, which is a very constrained and restricted environment. And this also helps then to achieve these challenging goals. You may be afraid and scared about what the figures that Markus presented at the beginning with the 6 nines, 8 nines, with the 1 microsecond and below. But it's a very controlled environment, and this makes it easier to achieve these goals. Therefore, it's really a lot of potential and also a lot of potential to actually achieve the demanding requirements that we have. And just to underpin this a little bit more, I've included here a figure that has been published basically in a recent study by Ericsson together with Arthur D. Little last year, probably most of you know that, which shows the revenue potential basically for ICT players for different vertical industries. We see here the usual suspects, energy utilities, manufacturing, public safety, and so on. And you see that manufacturing here is the second largest one, the 90%, and 90% of a large number here. So it's the second one. Energy and utilities, according to this study, has even more potential. But you have to keep in mind that the investments that we need to leverage this revenue potential are much smaller for manufacturing than for the smart grid, for example. And therefore, this again shows that manufacturing really is the killer application and the most attractive one here. So what does this mean? So if you know where the potential is, this means forget about this automotive stuff, forget about the consumer domain, forget about agriculture. So really put all our energy, all our focus on 5G for manufacturing. So to make it a bit more concrete, so why do we actually need 5G in a factory? And that's because we have this transition from the factories of the past to the factories of the future. Industry 4.0, industrial IoT, there are different terms for that. And the factory of the past basically was highly optimized for one specific product. So everything that we did, how we set up the production line was really optimized. And then we produced a product like a headlamp. This is in an old Bosch factory here. We produced it 1 million times and so on. And now the factory of the future looks more like this. So here you can see it's much more flexible, much more dynamic. We have automated guided vehicles, we have robots on moving platforms and so on. And everything is basically flexible. That means we can easily reconfigure the factory. But in order to be able to do that, we need wireless connectivity, and currently only 5G can really do the job here. So 5G is really getting the central nervous system basically of these future factories. So we see that only the walls, the roof, and the floor basically are fixed in the factory of the future. Everything else is mobile, moving, and 5G is the glue that ties all together. So and there are some selected challenges. We've heard about some already before, especially during Markus' talk at the beginning. We have this ultra-high reliability requirement. So the 8 nines was basically when we started. So in the meantime, we got a bit more realistic. We are talking about 6 nines, communication service availability, which is still challenging, but nothing that is impossible to achieve. We are talking about latencies in the order of 1 millisecond end-to-end. Also, this is something that should be doable, but it's challenging, but that's why you're all here. I mean, that's why we need research. Then it's also about synchronicity. That means if we have a closed-loop control system with a central master controller and several sensors and actuators, we need a very high synchronicity between the nodes. Here we're talking about 1 microsecond. This does not necessarily mean a jitter of 1 microsecond, but it means we need this synchronicity, and there are different ways then to achieve that. Then we need a seamless integration into the existing ecosystem. So a factory is nothing usually that is built on a green field. Sometimes this happens, but usually we have old factories which we want to upgrade. And then we have a lot of installed equipment there with existing communication technologies. And we have to make sure that whatever we bring into the factory can be seamlessly integrated. So therefore, the interaction of 5G with industrial Ethernet systems, with field buses, with TSN, which has been mentioned before, is really important and key. Safety and security, I think that's clear as well. I don't have to mention a lot here. But we also need new operator models. And also this is something that has been mentioned before. So the question is the traditional operator model that a mobile network operator sets up, deploys a network in a country like Slovenia, and then we just use the network also for our factories. This is really suitable for these applications. And probably it's not the best thing that we can do, and therefore there's this new notion of a private 5G network in a factory. And just to emphasizes a little bit more why we actually need private networks. So that's actually a Bosch factory in Gleichach in the very south of Germany. So the typical Bosch factory, if you're looking for a job and if you like nature, then just get back to me after the panel discussion here. And we would like to set up a private 5G network in this factory here. So why would we like to do that? So first of all, it's for performance reasons and to be autonomous, basically, from the public network infrastructure. So most communication inside a factory is local, from a control panel to a robot, from a programmable logic controller to an actuator, and therefore we should keep it local. There is no reason to go out of the factory to a base station located here and then back if the communication basically is only locally within the plant. And we want to be independent of the infrastructure around us. That means even if all connections are lost, we have to be able to maintain production ongoing for at least some time. And therefore, we need a radio access network locally, and we need a core network locally. So then security, privacy, these are also reasons, of course. So we want to keep full control of the data. It's very sensitive data. We want to keep full control of the equipment that is being used, people that have access to things, the algorithms that are used, and so on. So it's really very sensitive, and factory owners, factory operators are not willing to take any risk here. And if you have a traditional network operator, that's something that cannot be avoided. Then there are business reasons, of course. So factory owners don't want to have a vendor login. And if you let a mobile network operator come inside your factory, install his equipment there, you have basically some kind of vendor login, because then the hurdle, the barrier to replace the network operator is very high, because then you have to take out all the equipment again, install the new equipment, and then that's something that you also would like to avoid. And it's about minimizing costs, of course. So a traditional network operator wants to charge something for the service, for sure. And if there's then another factory somewhere else in this world which does not have to do that, it's just a competitive advantage for this factory. Then there are macroeconomic aspects. So yeah, fair and quick access to spectrum really becomes crucial for the competitiveness of the whole economy. So if in some countries this is possible, in others it's not, then you just get a disadvantage for the whole economy. And then this really is not just about a couple of €1,000, it's really about large amounts. And maybe the most important reason is liability. So I've shown you the vision, our vision of the factory of the future, where 5G is really the key enabler for that. But this means we depend on the availability of the 5G network and the communication services offered by the network. So what happens if we cannot get the 1 millisecond latency for one transmission, if we get a couple of packet errors in a row? So then the production line might stand still, and then the question is who pays for that? And that's where usually the traditional network operators become a bit quiet, because the potential damage is very huge. We're talking about millions of euros if a big car production plant stands still. So it's not that you just switch it on again and then it's up and running again. It really might take quite some time, cost quite some money. And therefore the liability is really a problem. Also because the network operator only has control of the network, but not of the production facilities. But basically what makes out a performance is the full system, so the interplay of the communication infrastructure and the production facilities. Therefore, we think it's very important that there is one party which can control everything, and of course, this has to be the factory owner then. So there are very good reasons for that. Let's have a brief look at the status quo, and I have to speed up a bit. There are two things basically that need to be considered, two main things. The one is the regulatory side, and the other one is the standardization side. And on the regulatory regime, and we will have the talk from Bo later, so I'm already looking forward to that. But there are some innovations ongoing as well. In Germany, for example, so I'm from Germany, that's why I'm very familiar with the situation there. There is a new idea of allocating spectrum for 5G, not for the whole country, but with local or regional spectrum allocations. That's really something new that we didn't have before. So the plan is to have this 5G pioneer band, 3.4 to 3.8 gigahertz, and only the lower 300 megahertz are allocated in the classical way. The upper 100 megahertz will be allocated on a regional basis. So there's still the question if we need a guard band of 20 megahertz here, but even if it's just 80 megahertz, it's still something we can work with. And that's really new and highly attractive because this enables us then to deploy private 5G networks in a factory, for example. And it's also very attractive because this may stimulate innovation and competition. I mean, completely new operator models may pop up. Maybe nobody of us can really think about this. it may stimulate competition, and it's always good also from a regulator perspective, certainly. So we have something similar in the United States with CBRS, which will go live later this year. And of course, the general option that we always have is subleasing of spectrum for a factory, so that we do subleasing from a traditional network operator, which works, but which is not really the preferred solution, because then you are still somehow depending on the network operator. And then we need support also from standardization. And there's also something ongoing in 3GPP. And of course, the industrial community is also engaged in that. We've heard about it before, also during the very first talk of Markus. So there's the idea of private networks that's been picked up by 3GPP. Currently, in 3GPP SA1, 3 different network types are distinguished: the classical PLMNs, so the classical wide area networks, and then we have 2 different types of private networks. Before, they have been called private and restricted, if I'm not wrong, but then there were quite some discussions, and that's why people said, okay, let's call it type A and type B for the moment, and maybe we find a better name later on. If you remember, this was the case with LTE as well, so it was just a placeholder, and then at some point it really became the permanent name for it. And type A means basically it's a private network, which is very similar to a traditional 3GPP network, so we use 3GPP credentials, SIM cards. We can have in- and outbound roaming to PLMNs, so it's very similar, but the access is restricted to a subset or a certain group. And then we have the type B networks, which are more flexible. Of course, we use the same radio access technology, but we have our own security mechanisms, our own credentials. But on the other hand, we cannot really have roaming to a PLMN because it's different mechanisms that are in use. And this also supports then different flavors of private networks, and that's really the basis then for having these new operator models in a factory, for example. So maybe I will skip that for the sake of time. These are just some further challenges. Before I conclude, I just want to say a couple of words about this 5G Alliance for Connected Industries and Automation, which we have heard now several times before. That's basically a new initiative that we have established formally in April this year with a goal similar to 5G AA, so to bring all stakeholders together dealing with 5G for Industry 4.0, for smart manufacturing, which includes the OT industry. So OT stands for the operational technology, classical industrial automation companies, machine builders, factory owners, and so on. And on the other hand, the ICT industry with chip manufacturers, infrastructure providers, network operators, and of course, we also have academic contributors to just support the discussions and so on. And we have publicly launched this at Hannover Fair at the end of April this year. Hannover Fair is the largest fair for the industrial community in the world. And we have 5 different working groups which reflect a little bit what we are doing there. So we have one working group focusing on use cases requirements, another one on spectrum and operator models. So especially these discussions about private networks and what a private network is, how much spectrum do we need, and so on. Then we have a working group focusing on architecture and technology, liaisons and dissemination, just to closely interact with the external community, including Industrial Internet Consortium, Platform Industry 4.0, Multifier Alliance, just to name a few. And we have validation and tests, where the task is to check and analyze if we need special certification procedures, for example, and where we also want to trigger some special testbed and trial activities out of 5G SAA. So far we are 31 members. So the last member that joined is ABB just a couple of days ago. And we are still growing, and I also would like to invite everybody here. So it's an open organization. You're welcome to join us and to support us in making 5G for the industrial domain, which, don't forget this, is the killer application for 5G, will become a big success at the end. So that's it. Thank you.
Thanks.
So let's see.
Good afternoon, everyone. My name is Bo Andersson. I am regularly the chief economist at PTS, the Swedish Post and Telecom regulator. And today I'm here in my role as co-chair or co-rapporteur at the RSPG 5G working group. And RSPG, that's the Radio Spectrum Policy Group, which is a high-level group that is advising the European Commission on spectrum issues, and consists of all the member states of the European Union. And it's nice to hear what the killer application is. That's one of the things that we've been thinking about. What could it be? So now I'm glad you told us. It's because it's what we learned from just a few. What we heard from the previous speakers is that we need a lot of spectrum to do all this. And of course, part of that is the role of the spectrum regulators to make sure that you get spectrum into the market. And from my perspective as an economist, I look at the spectrum work at PTS in the way to make the spectrum available to maximize the benefit society of the use of the spectrum. And of course, this means that we should not make sure that you get spectrum for just one killer application. We should make sure to enable the market to work in a good way to make the good applications grow, and from the good business models, make sure that they can thrive and also then deliver lots of services to us as end users in the market. So it is of course important for us to know which will be the killer application, but we should also make sure that we get a level playing field out there, so all applications get a chance to grow. And what we've been working with in RSPG is over the last years is trying then to identify frequency bands to get out there to focus on for the EU within the European Union. And in doing this, we try to base it on both a low level, medium level, and a high level in order to get both possibilities for coverage. And we pointed at already existing EU harmonized mobile band, and for example, the 700 megahertz band is the one we focused on there. And to get capacity, there the band that's been mentioned here, 3.4 to 3.8, it's one of the ones that have been pointed out a lot, which is a primary band for 5G. That will be capacity band, especially in urban area, denser areas. And then for future services, of course, it's even higher up, the 26 gigahertz band, which is pointed out as the pioneer band in Europe. And this is the first opinion that was published by RSPG pointing at this, and that came out in 2016. And this you can find on, if you haven't seen it, on the RSPG webpage. And after having done this, we continued the work looking at more strategic and regulatory issues, focusing on having pointed at these three different bands. And here, of course, then you start to wonder how do you then use this? I mean, and sharing issues, as you talked about, these bands have different characteristics. This means you can probably, it's interesting to think about and wonder how can we maybe use this in different ways that we've been authorizing before, because we have both legacy issues here. We have existing use in these bands. We have to probably share with those users if that's possible. That would be probably simpler and more efficient than just to clear bands. Would take much longer time because timing is a crucial issue here. We hear that we need to do this really quickly. We need to get this spectrum out to the market in order to get this developed. So this is important. And if we look at this, that then gives us different challenges towards authorization models. And I think the German example here, quite interesting on the C-band, the 3.4 to 3.8, how to look at that. And we've coverage, I mean, from all perspectives, it's really important to get coverage because 5G is something that should be possible for everyone within EU to use. So then we need to think about that. And then, of course, verticals and the internet, all the connected things and intelligent transportation systems and automated cars and all that. I mean, this is really something. And here also coverage is, when you go across borders, I mean, it becomes important that your car continue to work when you cross the border, of course. How do you make sure that you have key performance indicators, perhaps, to make this work all the way. So it's really important to look at all these aspects, and we've been trying to do that to a certain extent. And also ultra-dense network considerations, and then, of course, what happens after 26. If we go further up, we may need more capacity, and then you have more bands. What should we focus on there? That's also something that we looked into. And this is the second opinion, came out and was published, I think, in February this year. It's also on the RSPG homepage. So looking forward then, I talked about that there is issues of what's already being used in the band. We now have to try to figure out, because it's one of the things that we pointed out in those opinions that have been out, is that you need a lot of this. If you look at the 3.4 to 3.8 band, it would be ideal if you could open up so that those who are interested in using this could get up to 100 megahertz per user for getting really a lot of capacity in this band. But that means that you need to do something, and this looks very differently in different parts of the member states. So what we're trying to do here is trying to work on good examples and ways to move forward in a good pace to get this fragmentation and get it more defragmented in order to make possibility to distribute the 3.4, 3.8 band in a good way. And then what we've just heard is also important for looking at how to authorize these bands, because how do you make it in a good way so you can get all these verticals to grow and use this? And should it be the traditional mobile network operators that work with this, or should it be new networks that are maybe run by industrial companies like Bosch, for example, in their own facilities? Or should it be, or will it be kind of some hybrid solution? What type of bands should be used for this? And the way we've been already in the first two opinions, we tried to get a sense of what this business model would look like. Because if we can see what the users need, then it could be more simple to adjust and adapt the authorization models for how to distribute these frequencies, this spectrum. But from the beginning, it's been very hard to get a really good sense. I think now it's finally now becoming clearer and clearer how these business models or these models will start to look. Because so far it's been very important, we've been pointed at, that we are extremely clear and long-term stable, and at the same time extremely flexible, which means that is a really hard balance to strike. So, because if you don't really know exactly what you need, you want the regulator to be flexible in the way you authorize the spectrum. But at the same time, these are long-term investments that need to be made in lots of industries, which means that you need to know what's the thing that is the decisions are for a long term. So that's why we are so interested in, and we've also been running a lot of workshops within our own group with representatives from these different industry groups in order to get a clearer and clearer picture. We're very appreciative that this has been possible and that the industry groups are coming to us to talk to us and really try to explain what their needs are. And we're still trying to work on how to get this into some policy implications that could be viable for all of the member states. Because this is, of course, also a challenge. All of you who've been working with cross-border negotiations and trying to figure out how to work with things, you know that it's always a challenge to agree on something. And this we need to do here in order to make it a clear statement. And I think this is kind of then moving into my last point here, which is that we try to look at good examples across the European Union and also outside of the European Union. How does this work in other places as well in order to roll out 5G in a good way? And I think one way of getting there is to having these type of discussions. So I look forward to interaction from the public as well, from all of you here in the rest of the discussion in order to move us forward in understanding how to make this happen. Thank you.
Thanks a lot for all these good presentations. I think time is now running, and maybe you have already some burning questions You have still 50 minutes to go. Not yet. Maybe then we start with first from my side. So I understand this a little bit as a joke. 5G we use for manufacturing, and we wait for 6G for, let's say, the other verticals, of course. No, coming back to be more serious. Maybe we should explain also what is the necessity for having autonomous driving and from the manufacturing point of view on 5G. So from the end user perspective, maybe Mikael, you can start first. Why we should have this autonomous driving from the end user perspective, and why should 5G be part of that? Maybe you can elaborate.
Yeah, if we look into the future in the longer term, we see when we have a large penetration of self-driving cars on the road, then we definitely will need communication between the vehicles to have both traffic safety but also efficiency especially in the urban environments. And in this case in the future, we probably will also need not just inform each other where we are and so on and what we will do, as the intention is with the vehicle-to-vehicle communication systems with 802.11p or the first release of the cellular V2X standards, but also to have like cooperative sensing. And that's from a end user point, it will increase the safety and you can relax and you get a smooth transport from A to B, so to say. And in that sense, maybe you can, and also for the community, I mean, in the future, you can reduce the traffic lights, just have optimized traffic flow by communication in intersections, but I mean, it's very far beyond.
Mm-hmm. Thanks a lot. And Andreas, from your side, maybe you can elaborate why we should cut the wire and should use wireless in factories.
Yeah, before I answer that, I just want to say again, it was not a joke with the application of 5G. Of course, it is serious. And I outlined the idea of the factory of the future, and I hope that this already shows that for that we really need wireless connectivity. The question is, why do we need this factory of the future vision that I showed? And that's not something new. I mean, we have this trend towards Industry 4.0, the industrial IoT, I mentioned it before. This has been ongoing for quite some time, even without 5G. And this is because manufacturing is always a race. It's always a race. On the one hand, you want to make things cheaper, to produce things cheaper. And on the other hand, you have to react to the market. And we see we have now a globalized market. That means competition is increasing. At the same time, consumers ask for more customization. I mean, nobody wants to buy the same Volvo, so it would be good if there are several different models and so on. And in order to enable all this, we need this high flexibility. I mean, I showed the example of the factory of the past. This is really one headlamp. We produced it a billion times, and I mean, it worked in the past, but now it doesn't really work anymore. So in the future, products will be different, up to lot size 1. It means that no product is identical to another one anymore. We have to quickly react to different demands in the market and so on. And for that, we need this high versatility, this high flexibility, and 5G is the enabler for that we see currently. There's no technology that really can be compared to 5G. I mean, Wi-Fi is not good enough. The other technologies, wireless technologies that are out there are not really able to satisfy the requirements, but 5G promises at least to do the job here.
Mm-hmm. Okay, thank you. You mentioned also the need for geographical licenses. Could we also apply this for, let's say, V2X communication, for V2E communication? Any views on that, so that we just use it along the highway, along the roads?
Yeah, I think it will be a very interesting investigation for the industry that we represent, and especially from the regulatory perspective. That if we can share a frequency band between two verticals, one that is split between the manufacturing for inside factories and for along, as you mentioned, Markus, on highways, and see if that could potentially coexist. That definitely would be interesting to investigate.
Mm-hmm. Okay. Please raise your hand also if you have a question. I think it's also, okay, on the right side. Well, now we have stimulated a lot of questions, please.
Hello. My name is Alex Gallis from University College London. Coming from academia, I can see, or I can put together the following assumptions: that there are no needs to enhance the business of operators with verticals in order to ensure that 5G is deployed, on the grounds that actually any operator who is not going to deploy such a network soon will probably have massive problem business-wise, because all the others are doing across the world. So it's catch now, or moving very fast. With this assumption, which I believe that is true, in particular, I see that in China, the major operators have massive plans to change their massive 4G infrastructure to 5G infrastructure, which is even more than in Europe. And also, I'm fully aware of some of the plans of the European operators to move to 5G anyway. Therefore, the verticals are some sort of bonus. So there is no need to look for a special application which will, let's say, make sure from the vertical will pay off with this interaction. The flexibility of the network is a name of the game which is offered. So in that sense, my question to the panelists is as follows. As I understand it, one offering to the vertical is the concept of slices, which is like a partitioning, secure, and otherwise network for their use, which can be switched on and off as their desire, could be managed on. And the question to the panelists is that what sort of characteristics actually they see in the use of such a slice if they want to use it? Because this is clearly an issue of 5G delivery. So once again, what characteristics, usability in terms of slicing you're looking for from the offerings from the operators?
Okay, so you actually ask what is the benefit of the slicing concept in terms of vertical business, and maybe our colleagues here from Nokia and Ericsson are able to answer this question, because I think it's more a telecom vendor, but also an operator, but we don't have operator right now. So I would like to delegate the question to you, if you have an opinion about the slicing benefit for vertical business. Sure.
Yeah, I'm not sure I fully follow the details, but I mean, overall in terms of the slicing aspects, as they've been talking about, if you can benefit, for example, the spectrum, if you can split it between different verticals and then sort of use the same part of the slice on that part, it's of course beneficial. And in terms of splitting, I mean, already jumping back to this enhanced MBB, massive MTC, and those type of thing, URLLC, then you want to share and split the resources in a way. And I think that is one part of 5G. So in terms of the slicing, you need to split the resources, because you won't be able to fulfill these truly high reliability numbers, 99.99, some number of nines. At the same time, go for the highest mobile broadband, megabits, gigabits per second. So as I see, the slicing is sort of fine-tuning for the needs of the particular, in this case, sort of zooming into the vertical and the actual application that you're looking for. So for example, the traffic safety versus infotainment in V2X, you have the traffic safety part. You need to really pay attention if something happens quickly, while the infotainment, you take the opportunity to collect a big bunch of data when sort of you have a good channel, for example.
So maybe I could continue comments on this, the role of network slicing here. I mean, as discussed, you can see that from verticals, the requirement is quite different. I mean, if you are thinking about factory use cases, and maybe if you are taking, like, for example, using network slicing to support the factory use cases, as discussed earlier, there could be, like, for example, just like a sensor type of device, and then there could be, like, also like a robot control, etc., which need a much high requirement. And then in that way, basically, you could even inside trying to set up some kind of resource specific for different usage. And also, I mean, when we're talking about resource, then it's not only from the kind of area interface point of view, but also from the core network. Another example could be like when we're talking about a support time-sensitive network. And then the current weird operation of time-sensitive network is like you are reserved not only the resource for the transmission or reception, you also reserve the resource to do the computing. I mean, that is also another way maybe trying to see that how we can support, for example, the TSN with wireless communication. We need to think that, like when we define the slicing part, actually we need to take all aspects into account when we trying to really fulfill the requirement from the use cases. Yeah.
Okay, thank you. I hope this answered a little bit the question, but I saw also other hand signs.
I had the question.
Okay, maybe first
actually the first one
on the right side, but we need the microphone.
The first one was actually a comment, because it seems to me it's very interesting that automotive industry is very much involved in 5G with AA and through 3GPP as well, because it seems to me that the automotive is actually in the center of the pyramid, because it requires high bit rates, it requires ultra low latency, and it requires, of course, sending some information from the sensors for maintenance, servicing, etc. And maybe some comment on that. The other thing is actually a question to the gentleman from RSPG, whether Europe thinks about maybe releasing 600 megahertz spectrum, what happened in the United States, I think.
Okay. I think the first question was to explain again the purpose of 5G in V2X. This is what you want to ask. So why we need this? I think we explained it actually, that we need 5G to push away the sensors and the URC for platooning. I think was clear. Maybe you can answer the question about the US citizen band, the broadband.
No, could you say it again? I didn't catch what you said really. Could you just?
So the question is, what about the spectrum, the citizen broadband spectrum in the US? How to use that, or is this what you mean? You were asking about the citizen broadband spectrum in the US, how to use this for, or how to mutate this in the licensed spectrum. This is what you mean for 5G. Okay, so because I think it's unlicensed or just for a certain purpose, but it's not licensed for the operators right now. Question is how to change this spectrum into licensed spectrum.
The 600 megahertz band, which is the broadcasting band today.
Yes, the C.5.
Yeah. Yeah.
Yeah. Yeah.
I think, I mean, that's if this is to happen in other places, you have to move the broadcasting out of it, I guess. I mean, that's not my decision to do. But it's of course, I mean, all those low, like the 700, 800, 900 megahertz band are really, really important for coverage. And of course, this same characteristic goes for the 600 megahertz band. So, those are not really capacity bands, but they are good for getting coverage. So the more you could use for other purposes, of course, it's good for that. But of course, then you have to make sure that you take care of all the legacy users in the band that are already there, and find a good model for them moving or something. So that would be my answer. So, but as far as I know, this is not. We focused on the 700 to start with for 5G for Europe.
Okay. I think there was one hand sign from the lady on the right side. Maybe you can raise your question, because time is really running. It's exactly 4 p.m. and maybe 1 or 2 questions. And
okay, thank you. Monica Buscher from Lancaster University in the UK. I'd like to hark back to the keynotes this morning and ask how we can support a human internet or a human 5G. And I'd like to give you an example from public safety. in the UK, we had an incident at Alton Towers, a fun park, and one of the rides broke down, and a massive casualty incident happened. And so when the emergency medicine staff arrived, also the police arrived, and they were wearing body-worn cameras, and they were filming everything. And the emergency medical staff were very concerned about that and felt intimidated by that, because everything they did was being recorded, and who knows what that is going to look like if it gets into the public domain. So my question is, what can we do to support not just the infrastructural technical innovation, but also human technical innovation? So what can we do to develop techniques and technologies to support trust in the technology and ways of controlling the information flow?
Okay. You want to answer this again? I think the human internet is probably about emotions. It's about GDPR and to protect privacy, but maybe you can comment on that. It's my feeling to go in this way. On human internet, what are the technical names for that?
Yes, it's a big topic. Human internet. I think the privacy. There needs to be within the society a common understanding of how much we're willing to share. At the moment, maybe people are sharing quite a lot of their information without really considering it. You're clicking in that, yes, I want to use, for example, this Wi-Fi access without reading sort of the legislation document behind it. So I think it needs to be brought up sort of on a quite high level to these privacy type of aspects of the society.
Okay.
Yeah.
I think maybe one last question, because then we are over time and then we have to close. There's the lady in the middle, I think, yeah. The last question.
Hello, my name is Mita Pavšek. I'm from Slovenian regulator ACOS. I would just like to ask the panelists from the industry about this possible new spectrum for 5G verticals. Of course, one possibility is to allocate one part of the core band for these industry verticals, but maybe in future there would be on the same geographical area another demand from some other user. Would you support kind of having spectrum for such verticals as well in some 3GPP bands which are not harmonized yet in Europe, but are used in other parts of the world? Thank you.
Okay, thank you. I think it's about spectrum sharing between different user groups. Maybe Bo, you can comment on that. What is your consideration?
I think it was directed to the verticals or
I think to the panelists in general,
yeah,
but,
okay, yeah.
But maybe you have some deep insight about the vertical spectrum. Who wants to answer this? Maybe you are deeply involved in the spectrum sharing discussions.
No, as I said, it's probably a good way to use this as we go higher up in the bands and the different characteristics of the frequencies change. It could be interesting to and we are looking into from RSPG perspective and from the different regulatory agencies in all the member states and I think all over the world basically. In how to use this sharing as a way of increasing the value of the spectrum. And I think that possibilities are quite big because you can use it probably within factories. You can use it for other uses in certain regions, and you can also use it, for example, in mines where you are below ground, which is a very good, where you probably won't disturb anyone that you know of, at least. So it's, I mean, there are definitely lots of possibilities, and I think it's this needs to be elaborated in a good way by the regulators, so we really can get the most value out of the spectrum. And I think it's the limits are what the business model can do with this. I think I mean, you have to work out ways of making this profitable, because it is probably also connected with making fairly large investments in these different sectors to get this to work. And I think it was really interesting to see that pie chart from the different sectors where you have, from the Ericsson study that you showed, because obviously there is a lot of money in here to use this, and this should mean that this will materialize, I think, these investments, and of course then we as distributors of spectrum should be there to make sure that spectrum is in place.
Okay, I think we are over. Thanks for the question, and I think the answer is also in place. I think probably we should repeat this next year again in the EuCNC 2019 is a still hot topic, and I would like to thank you for your patience and questions, and also thank the panelists for your good presentations. Thanks again, and give them a applause. It's over now.
Short discussion.
Yes.
Short discussion.
What was your last comment? What were you going to say?
I have to go to the airport.
I just wanted to say it's important to think about new ways, at least, how you can discuss before. So, I mean, maybe it's not the best approach that I've presented now that Germany is going to discuss, but at least it's the first step.
It's one way.
I have to go there, but thanks for coming.
Thank you very much.
Sorry, I don't have more time.